If you have these numbers and we observe that 0 is within these 2 and 8, we can say that we have how many significant figures here? 1, 2, 3, just 3 significant figures. So it's a very, very important topic here. So significant figures, units, very, very important. You can call your base unit. What is the base unit for length? Meters. The base unit for time? Seconds. The base unit for luminous intensity? Candela. Those are base units that we should also know about too very, very well. Now, quickly, we go to the next question. And the question there is testing us on a concept that we should know about very, very well. Yeah. Let's quickly do it. So we can say that for question 1, the answer is B. For question 2, the mass of a metal cylinder was determined on an analytical balance to be 50.208 grams. So the mass is equals to 50.208 grams. The volume of the cylinder was measured and determined to be 5.6 mil. So the volume is 5.6 mil. Mil can also be said to be centimeter cube. The density of the metal cylinder expressed to the proper number of significant figures is, now, back here, we could say that 2, 3 is the significant figure here. So that is 2. Now, but here, when we calculate the density of number, now, so we want to try or solve this question, and noting the fact that we must put it in the proper significant figure. Let's recall, density is the unknown here, but density is equals to mass over volume. Mass over volume. If it's mass over volume, we need to recall that density will be equals to 50.208 over 5.6. Quickly punch my calculator. 50.208 divided by 5.6. So that is 8.9657. Once I'm solving question, I like putting in after the decimal place 4 BP after the decimal place. Why? Because this is not yet the final answer. And to prevent error, and let's not forget that error is a topic under measurement here. So 8.9657. But the question is asking us that we should express the answer in a proper significant figure. Now, you can observe here, the significant figure here is 1, 2, 3, 4, 5. 5 significant figure for the numerator. For the denominator, we have what? 2. Now, when you are solving a question, either a multiplication or division is being used in the question there, we need to note that we put the answer with the lowest significant figure. That is, we round up the answer to the lowest significant figure. So here, you can say we have 2 significant figures here. This is 1, 2, 3, 4, 5. So rather than put it in 5 significant figure, put it in 2. So 8.9657 in 2 significant figure is 9.0. Please, 9.0 is the answer. 9.0. If you approximate, look at 9. The number after 9 is 6. Since 6 is more than 5, so you have to add 1 to 9. So 1 plus 9 is what? 10. So 0 carry 1. So 1 on 8, that is 9.0. So rule of significant figure. So it's one of the rules for rounding up numbers in expression like this. So sometimes in questions, you see, you'll be given different numbers and you are told to solve. And once they ask you to put down the proper significant figure, please don't forget that. Note that rule very, very well. So in the course of today's class, I will bring another rule again. So for now, we know that we have done one for multiplication or division. So that's 9.0. Let's not forget the unit, gram per mil. And the answer for that is B. B. Now, the next question here is precision in measurement is dash. That's a very good question. Very, very good question. Now, in CHF 101, let's not recall measurement. So far, we've talked about units. We've talked about significant figures. Now, I want to dive into accuracy and precision. Very important topic in this course. A topic that you always see in your exam. So please, pay attention, guys. Please pay attention. Now, accuracy and precision. Now, you see everybody, I know in this class, we have footballers in this class. And when we see the fact that Nicholas Jackson is losing chances, we say that Nicholas Jackson is not accurate, he's not scoring well. Because when he's meant to score in the goal post, he's playing the ball up. They know, what is he doing? What is he doing there? So accuracy and precision is something that is very, very important. Now, in the question here that asks about precision, but it's still under accuracy. And what is accuracy? Accuracy is how close a value is to the true value. I take that again. That accuracy is the closeness of how a measured value is to a true value. It can be in different ways. Just for us to just have the basic understanding. Now, let's say for example now, the length of this board is 8 centimeter. Then I decided to now call Dio. Dio said, oh, Mr. Kelechi, I just take the length of this board. I'm getting 7.8 centimeter. John just comes out and says, John said, so I'm getting 7.4 centimeter. The girl just only come now. Biola by name now said, Biola just come. Biola now said, sir, I'm getting 7.9 centimeter. Don't they even measure himself? So everybody is measuring the length of this board. But we observe one thing, that the true value of this board, which I did by my own self, the true value, maybe from the manufacturing company, is 8 centimeter. But I'm also trying to do that with 8 centimeter. But I'm just calling Dio, John, and Biola to measure it too. But you can observe that out of the three of them, Biola is closer to the true value. He has 7.9 centimeter, closer to 8 centimeter, followed by what? Dio, 7.8 centimeter. I don't know what John is actually doing though. John is having 7.4 centimeter. So that is what accuracy. That is accuracy. So accuracy is not telling us that this value, the agreement of how close a value is to the true value. Now the question here is, see, ask about precision. So what is that precision? So precision is not trying to tell us. If you look at the questions there, I see the question. If you look at the precision there, if for a student that not know what precision means, they do not guarantee option B. Option B is telling us that closeness of measurement to the true value. That is accuracy, and that is wrong. But what is that precision today? So precision is the agreement of a measured values to what? To the true value. Please note that English here. Please note English here, please. Let me take it back again. I'll take it back again. That precision is the agreement of measured values. I don't say measured value, measured values. So it can be values. So it can be, now from this, now we can see 3 values here. 3 values here. So the agreement between the values here to the true value is what they call precision. So for instance, now, because of that, I want to just have a wider people to solve, to measure the length of the board. I brought in Lola. Lola measured her own and said, it's 7.92 centimeter. I call another person, Samuel. Samuel is saying 7.87 centimeter. Now, for instance, now, if I'm decided to what, let me just disregard Dio and John. I don't know what they are doing, they are playing on their own. I want to take these values now. You can observe that these values are what? They are closer to each other. 7.9, 7.2, 7.87, they're closer to each other. So the fact that there is agreement between these values is what they call. So let's look at the options here. They say precision in measurement is A, agreement between replicate measurements. Let's keep that aside. You know B is wrong already. We talked about that already. C, estimated in terms of absolute error. Difference between measured value and true value. No. So we can say from here that today, that precision measurement is agreement between replicate measurement. What am I replicate measurement? When this is what? The length of the board. So when you're now doing the same measurement over and over again, we call it a replicate measurement. So over and over again, 7.9, 7.9, 7.87 centimeter. The fact that we are still measuring the same, the length of the board is called replicate measurement. So the answer is A, agreement between replicate measurement. So it cannot be the agreement between measured values. So a true value. So you see the same thing. Now, I want to bring out something there. We've talked about greater and precision. I want to bring out something there. Before I bring out that question 4. They said the term that refers to the reproducibility measurement is very nice question, mostly asked in multiple choice question. So reproducibility means how well you can reproduce a particular what result, and the answer is precision, not accuracy. Please note that, not accuracy, precision. Now, let's go back to question 3 of telling us one in option G. They said difference between the measured value and a true value is not precision, but it's called error. So error is the difference between the measured value and the true value. Please note that it's a very important topic there too. I'll talk about significant, I'll talk about accuracy and precision. Accuracy and precision. Now I'm going into error. So error. So we can see that the difference between measured value and the true value is called error. Please note that very well. Write down your points. Write down your notes very, very well. Now, the next question, number 5. Which of the following types of errors can be traced to a defect in the measuring instrument? We are still under error. Please follow me. We are still under error. Let me show you something that you need to please put at the back of your head any day. Error. We have what they call random error. We have what they call random error, and we have what they call measured. We have what they call systematic error. Now, what is systematic error? Systematic error is an error due to flaws of an instrument or flaws in the design of an instrument. I take that again. Now, systematic error occurs due to flaws. Flaws means mistakes, errors due to flaws in an experiment that is done by somebody, or the design of the experiment, or to the design of the experiment. What is random error? Random error is an error that occurs due to uncertainty. What I mean uncertainty, it just have to happen. Like you don't have any power over it. So due to the uncertainty of a measurement, it just happen. It just happen. For instance, now, if I am drawing, when I was working in the lab, when I was in year 2, I was drawing a product of my reaction there, of one of my lab work. And I observed one thing when we did the lab. I put it inside in my filter paper where I had all the whole. So they said we have to dry fan. So now I'm drawing on that fan. I observed that with time, some of the particles were leaving. Now that I don't have any power over, it has to happen. So that is random error. So now the question is now asking us here that the type of error can be traced to a defect in the measuring instrument. To the measuring instrument, that is known as what? Systematic error. Measuring instrument. Yes. That is why we go to companies, you see the SON, very, very important organization in Nigeria. They always come to know, is your equipment calibrated well? They come to check. Why? Because of what? Because of errors that can occur. A simple error that can happen due to instruments here can cause loss of life, loss of properties too, and also loss of what? Of money. So that is why they don't joke with things like that. You have to check if your instrument is well calibrated very, very well. Now, we have now opened ourselves towards the random questions now. You probably ask questions. Now let's go to to the theoretical questions, because you still see theory questions too. So let's know how to apply what we learned now. Now, quickly, is that given the following attempt at a game of darts by 3 students, Usman, Diola, and Emeka. Usman, Diola, and Emeka. Usman, Diola, and Emeka. Usman, Diola, and Emeka. Describe the accuracy and precision of the student. Let's look at Usman. Let's look at Usman. Look at the targeted points there. We can say that Usman is not accurate. Yes, it's very clear. Usman is not accurate. He's shot 3 times. Only one is reaching the center. No, it's not accurate. Not accurate. Is it precise? What I mean by precise is the that point. Is it closer to each other? No, it's not precise. I don't know what the guy even did himself in the game. That's why he lost. Not precise. Now, Jola. Look at the targeted points there for Jola. We can see clearly that Jola 3 dart is in the center of the dartboard there. So we can observe that Jola is what is accurate. High accuracy. High accuracy. But is it precise? Yes, it's precise. The bodies are closer to each other. It's precise. That is what? High precision. High precision. Then we can look at Emeka. You can look at Emeka. Look at the center. The values are not closer to the center itself. Accurate. Not accurate. Not accurate. But we know for sure that is what it is precise because the values are closer to each other. So high precision. High precision. High precision. That's a very good question. You can see that they even put the space for you there. So high. So accurate precision for not. Jola, high. Emeka, not high. I hope it's clear. So it's a very, very important question like that. So it can be given a pictorial view or something, and you need to tell us what it's about. Question 2. Wow. We have to apply what we learned under error here. Let's apply it. I believe this because we touched all this already. Let's apply what we talk about error now. Let's apply it. Now, the conception of nickel in Nigerian coin was determined with visible spectrophotometer, and the following results presented were obtained. Now, if the true concentration is taken is concentration, that's the true concentration. The true is equal. Now, please note one thing very well. One thing. And what is that? You're giving the experiment. So the only way you can get the measured value is to get the mean. So in that question there, I have in the 6.5 plus 4.11 plus 3.59 plus 7.51 plus 3.95 plus 4.06 plus 1.48 plus 3.60 plus 3.76 plus 3.99 divided by, to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So over 10. So I have to get the mean. So quickly I punch my calculator. Please take your time when you are doing things like this, because a little error, it can affect your work. Please take your time when you are doing something. I believe you might have questions at the bottom. Please just keep them. We'll treat them. There's that have 3.97. So this is measured value. This is the measured value. So now I want to get the error. We want to get the error. And what is error? So error is, recall what is error. Error is equal to measured value minus true value. Measured value minus true value. So in that case, I have 3.97 minus 3.92. You can see clearly that is 0.005. That is the answer. That is the error. That is the error. Absolute error. Absolute error means even though it's minus, is 0.05. So we neglect the negative sign there. That's for the absolute what? Error, 0.05. The way now percentage relative error. Wow. Percentage relative error. What is relative error? Percentage relative error. Now what is relative error is equals to the relative error is equal to the error over or absolute error over true value times 100. So absolute error here today is 3.97. True value is 3.92 times 100%. Now we can now see clearly having more than 100%. That shows that something is wrong with the calculation over there. Something is wrong with the calculation. We have to go back to our calculation and see where we made mistake, or maybe the questions from the question were wrong. So can we check that? Plus 3.59. Then quickly punch my calculator back again. 7.51 plus 3.95 plus 4.06 plus 4.06 plus 1.48. I'm pressing my calculator again. Plus 3.60. I hope you are following from the slide we have. Plus 3.60. So that means we are still getting 3.97. That means from the onset, the error here was from the question itself. So we're having more than 100%, and that is nonsense. So if that is the case, but we all know the whole way we can solve such questions. We're not meant to get more than 100%. That is, we're not meant to get more than 100%. So that is a funny question. We move to the next question. The next question is asking us for distinguish between systematic errors and random errors. Systematic errors and random errors. Now, one of questions like this, please, you need to know something about chemistry. You're very well in chemistry, but if you don't know how to answer questions, then you don't know what you want. Now, you have a question, systematic error, random error. What you do is that you have to draw a table of such question there. So systematic error. So what is systematic error? You said again that is an error due to what? Flaws in the design of what? Of experiment or design, or a flaws in cannot determine. Why systematic error is called determinate error. And also you need to note that systematic error can be avoided. It can be avoided, but random error, they cannot be what? Avoided. So that is one way of, we have talked about 3 or 4 ways of distinguishing, of differentiating between systematic error and random error. And lastly, determine the answers to their proper significant figure question. And that's where I will give you a question for you to attempt. So quickly, let's see what we can accomplish. Now, the first question they're saying 2.034 times 4.6 divided by 5.1. Please, when you are doing this, don't give an answer. Don't run up yet. Just be patient and solve. Times 4.6 divided by 5.12. We have 1.8 274. This is what my calculator is giving me. This is what is giving me. In this case here, this is what is giving me now, my calculator. But I have to not forget the rows that I've learned. So look for the lowest significant figure. That is 1, 2. So 1, 2. That is what? 1.8. 1.8. That is the answer. 1.8. 1.8. The next question there, we have 25.996 plus 2.9. 25.996 plus 2.9. 25.996 plus 2.9. Basically, attempt something like that. 25.996 plus 2.9. That is 28.896. Now, how do we do this? How do we answer questions like this now? Now, because of the fact that there's no times or division, this is addition or subtraction. What we do is that look at the DP, the number of DP after the dot. So after the decimal place. So after the decimal place, here we have 1. After the decimal place, you have 1, 2, 3. So we have to do it in 1 decimal place. 1 decimal place. The answer of this is what? Approximate this. This is 9. 8. After 8 is what? Is 9. You have to add 1 to it. That is 28.9. This is the final answer. Now, guys, I have an attempt question here. Please let's try to attempt this question, and your answers will be collected in the chat box. Thanks for your time, guys. I really appreciate it. Meet same time next week. Have a nice day, guys.